So let's start with our first question. What is technology and how does it evolve? Let's start with the working definition that I give you, and that basically says that technology is a standardized solution to typical needs derived from knowledge about the world and embedded in a physical structure. So let's, for example, start with a much more intuitive technology than digital technologies, which is a dishwashing machine. A dishwashing machine is certainly a solution to a typical need that I have every night. Dishes gotta be washed, right? It is also derived from knowledge about the world, in this case, from knowledge about how to wash dishes. It uses warm water, it uses soap, which kind of soap it uses, the way it circulates the water. It also soaks the dishes sometimes for over an hour in order to loosen the dried food on it, right? So, yeah, it is derived from knowledge about how to wash dishes. In this case, this knowledge is embedded in a physical structure, the way the water is sprayed, the dishwashing machine, the way it works, right? And it's standardized. It fits under my kitchen counter, and the buttons are kind of like the same in every dishwashing machine, which enables even me to operate different ones of them, right? Let's go to communication technology. As for example, the mobile phone. This is Mr. Martin Cooper from Motorola who invented the mobile phone in 1973. A mobile phone is certainly a solution to a typical need. The typical need is how to telecommunicate. Tele stands for distance. How to distance communicate while on the go, while being mobile. It is derived from knowledge about the world. Mr. Cooper had to know a lot about electrical engineering and radio spectrum in order to transmit these waves. It's embedded in a physical structure. Bits and bytes have to go through transistors, and it's standardized. It kind of like all mobile phones are kind of like the same, but wait, they're standardized in a way that because Mr. Cooper here has a different phone as well, right? This is one of the first phones that he invented, these kind of like mobile phone bricks, right? Because they were so big. And this is a modern mobile phone. So mobile phones are standardized, which makes them mobile phones, but they also evolve. Take, for example, the iPhone. This is the first generation iPhone, and as we all know, the iPhone evolved. That's the iPhone 3G. The iPhone 4G then also changed a little bit in shape. The iPhone 5G had different applications. It grew a little bit in size, and the iPhone 6G Plus even grew more in size. So technologies evolve. Why do they evolve? Because our knowledge about the world evolves. We know more things, we know how to do more things, and we embed this knowledge in a physical structure. Therefore, technology evolves, and it evolves in these discrete generations, in these discrete jumps. So we can now take these observations and turn them into a theory, the theory of technological change. That's actually how it is called. So let's take another example from information and communication technologies. A typical need that we have is how to store high quality sound for later consumption. At the beginning, it was always a need, but we didn't actually have knowledge about the world how to do that before Thomas Edison came along in 1877 and said, hey, let's record information on a tinfoil wrap. Before that, there was no way you could store sound for later consumption. If you wanted to hear Mozart, you had to be present where Mozart was playing. There was no other way. But Edison came up with this genius solution. Decades later, we improved on this. For example, we created vinyl records that DJs still use nowadays. Then came along the cassette tape that I, as a child, was addicted to. I had hundreds of them. And the CD player came along a little bit later that used another technology to store the sound on an optical disc. And then the disc, the digital disc, the MP3, and so forth. One interesting thing in these waves of ongoing evolution is that they always seem to become shorter. So if it took 50 years to go from the tinfoil wrap to the vinyl record, but only 33 years to go from the vinyl record to the cassette tape, only 17 years from the cassette tape to the CD, and so forth. And this is one interesting thing that means that technological change accelerates. It always becomes shorter. And we can see that over the entire history of humankind. For example, guess how long it took us, humankind, from the domestication of fire back in the day. You know that we had fire in the cave, we found it. I don't know, lightning struck in the woods, we took it to the cave and we domesticated it until we discovered how to start fire. That means we had fire, but we had to take care of it because we had no idea how to start that again. We had to wait until lightning struck. Guess how long that took humankind to come up with this innovation? It took it 150,000 years. That's a long time. The time since Jesus Christ is 2,000 years, right? So 150,000 years. It's a long time. Many nights we were sitting in front of the cave, staring into the fire, and we had no idea how to start it. We were pretty much just coming from the monkeys, right? However, from the first time humankind took a flight, the first time the brothers Wright flew for 120 feet in 1903, it took only 66 years until the man flew to the moon. So innovation accelerates. Things always become short. That's because our knowledge accumulation works through a combinatorial logic, and that accelerates. We don't have too much time to go into that, but that's the logic behind it. So we have these waves that always become shorter and that lead to an acceleration in technological progress. If we draw a line through this here and we exchange performance with technological progress, we have our theory of technological progress, right? That's actually how it works. So we can now see how this theory of technological progress applies to the evolution of modern information communication technologies. This is, for example, the technological trajectory of telecommunication technology, which started, as I said, for example, with the Pony Express, right, with postal mail, and then came along the telegraph. Now, the telegraph at the beginning also was horribly slow. In 1858, so that's about here, when Queen Victoria of England sent the first telegraph over the Atlantic to President Buchanan of the United States, it took 17 hours to transmit this 100-word telegram. That's about 10 minutes to transmit one word, about 2 minutes to transmit one character. It was horribly slow, right? Then telecommunication technology evolved in leaps and bounds, in discrete steps. For example, the telephone came about, the broadcasting, TV and radio came about, telex and teletype, fax, and then this is the digital technology which came about here. And nowadays, for example, the transatlantic cable networks between Europe and the United States transmit about 1 terabit. Now, it's terribly big, so it's kilo, mega, giga, tera, right? 1 terabit per second. How much is that? If I would lecture in the speed that I'm talking right now, about 120 words per minute, and I would lecture since the time of Jesus Christ, 2,000 years ago, and I would talk incessantly, day and night. I would not take a break. I wouldn't even sleep. I wouldn't eat. I would just sit here and lecture the entire time. We could write down all of these words, put them together, and transmit them over the Atlantic in less than 1 second. 1, 2. They would all be gone. Quite an improvement from the time that Queen Victoria sent her telegraph, right? Now, as this example also shows, of course, a theory is always an abstraction, right? So this example does not perfectly fit these abstract curves that I showed you in the former slide, but it is a discrete improvement from one technological way to satisfy a typical need to the next way to satisfy this typical need. In this other case, for example, here we have storage technologies. We can see these waves very clearly. This is the evolution of hard disk. This is the evolution of RAM, of random access memory. Very nicely, you can see these waves here. This is the technological trajectory of computation, starting with manual computation. You might be aware that before the electrical computer, these kind of like abacus machines were one of the dominating ways to compute, to make computation. That's a Japanese master, an abacus. And you can see that this Japanese master was able to compute faster than even the first electromechanical computers. With the innovation in the 1950s of vacuum tube-based computation, for the first time, the computing machine overtook a human computer. And then later on came the revolution of the transistors and, of course, the microprocessor, which multiplied and just carried us away and created this incredible computational capacities that we all carry around nowadays in our mobile phones and so forth. So, in a nutshell, to summarize, technological progress and understanding technological progress will be very important for you independently if you will work in the private sector company, even a technology provider, or in the agricultural sector if you will work in the government, in the public sector, in an NGO, in a university, doesn't matter. You will always interact and be driven by technological progress. So what we now understood about technological progress is that technology itself actually is derived from knowledge about the world, which is embedded into a physical structure. And by improving our knowledge of how things work, we create different generations of technologies which always provide a more advanced solution to a typical need that we have. And this evolution happens in discrete jumps, which leads to a punctuated evolution of technologies in consecutive generations, which overall leads to what we know as technological progress.